Thank you everyone for joining today. Welcome, good afternoon. My name is Emma. I am the program coordinator for the Office of Postdoctoral and Graduate Student Education and Research Development Affairs. And welcome to our next session in our Trainee-to-Tenure Track Program. This series, the goal is to support early career scientists in cultivating skills necessary if they choose to transition into an academic career. And last week we had Dr. Robert Mahley, President Emeritus and founder of Gladstone Institute, speak to us about the art of lecturing, which he's generously been giving for over 25 years. And today he has returned for the Chalk Talk, how to prepare a Chalk Talk for an academic position.
Okay, well, let me add my welcome to all of you. I see some old friends that have come on and a number of new people. That's outstanding. I understand that we have participants from UCSF, UC San Diego, Lawrence Livermore, Genentech. So it's a pretty wide audience, and I'm really pleased to have the opportunity to share with you about Chalk Talks. So let me start with the slides. Today, as you know, we're going to talk about Chalk Talks, which are somewhat mysterious to some individuals, and we're going to consider presentation skills that are associated with the Chalk Talk and also approaches to job interviews, both in academia and in companies. Chalk Talks are now widely used as a major part of job interviews. This has happened over the last probably 10 or 12 years that they have risen in prominence and importance to individuals seeking a job. So what I will discuss today are best practices that I and others, I've had help from a number of other people here at Gladstone, what we've observed as a good presentation and of course what we've observed which hasn't worked so well. I've served on dozens of search committees over these many years and also continue to attend Chalk Talks. I guess just this year alone, I've attended 6, 7, or 8. And so I've tried to pull together some thoughts on the topic that may be helpful to you. Soon, hopefully, we'll be out of this Zoom mode and we can actually have Chalk Talks in front of a whiteboard. So let's talk about what is a Chalk Talk? Why are Chalk Talks used now so widely? They are used by search committees to assess the suitability of a candidate. And there's two levels of suitability that's being measured, and that's professional, that's your research, but also on the personal side. What are you like as an individual? What are you like if in fact you were to become a colleague? A Chalk Talk is an informal format to learn about you, as I said, as a person, as a colleague. But don't mistake this informal format for being simply a chat, or you come and share a few things and everything's fine. It's not that at all. It shouldn't actually be called an informal format because it is very formal. Now, there are no slides that are used. You simply stand in front of the whiteboard and you talk and you write on the board. There are two ways that the Chalk Talk is used. It follows the formal slide presentation, and And the Chalk Talk may follow immediately later in that same day. That does occur on occasion. On other occasions, it may occur, the Chalk Talk may occur days, weeks, or even in some cases, a few months later. And often, as I've already said, it's the most important determinant for you getting a job. A Chalk Talk often determines who will get these limited positions, but to say it another way, I have commonly seen the Chalk Talk determine who doesn't get the job. A good seminar, yes, a good seminar, but a poorly prepared Chalk Talk can in fact sink your offer for the job. Now, what's the typical length of a Chalk Talk? Well, it varies, usually 30 to 50 minutes. 50 minutes is probably more common. There are many interruptions in a Chalk Talk. This really is a dialogue, a talk between you and search committee members. So you need to plan carefully what you want to say. Now, if it's a 50-minute Chalk Talk that you've been asked to give, you should probably prepare for about 35 minutes because there will be interruptions. Now, when you are preparing your Chalk Talk, you need to consider the nature, the type of job that the job search is all about. What type of a candidate is the organization looking for? It may be a focus position with specific expertise. Electrophysiology and neurobiology, for example, is a specific focused search, but they may also be casting a net. The general field of looking for a geneticist could be Drosophila, it could be mammalian. Some searches actually are just looking for what they call the best athlete. It doesn't really matter what you're doing as long as you are the best. This, of course, the type of search impacts how you structure your Chalk Talk, general or specific. But the nature of the search determines the type of talk that you're going to give, but it also gives you a clue as to the composition of the search committee. So what is the composition of the search committee in most searches? Well, usually search committees are a mix of senior and junior investigators. And they approach a Chalk Talk a little differently. Senior investigators tend to be more at the 40,000-foot level, whereas more junior investigators are more detail oriented. Often they have, in fact, usually, they have diverse backgrounds. There usually is an expert, one or two experts in the area that you are being interviewed for, but there are a lot of generalists that are involved. Now, all search committee members tend to be busy people, and so you have to be very efficient in the way you present. It will not go over time. The chairperson will stop the proceedings once the designated time is reached. One or more of the search committee members may actually assume an attitude of testing you, even provoking you to see how you respond to a challenge. You will know, or you should know, the names of all the search committee members. You can always contact the contact person that's interacting with you, which is usually the chairman of the committee, and you can ask them specifically the number and the names of the individuals on the search committee. In fact, you must do that because you need to look them up. You need to know who those individuals are, know their area of expertise. Think about how they will question you. You can ask your PI, you can ask other investigators about a particular person. What type of a person is this individual? So That's a quick overview of what a Chalk Talk is, what's the nature of the job search and how that determines the talk, and most importantly, the composition of the search committee. Are there any questions at this point? Please unmute yourself and ask anything that you would like, if you have a question. Well, let's go on and consider then professional attributes that a search committee is looking for, and equally important, the personal characteristics of the particular recruit. Hiring the correct person for the right job determines the success of an organization. A wrong recruitment is painful for everybody. It's painful for the organization, the university, for Gladstone, and it's painful for the employee. So let's consider, what are search committees members looking for in a candidate? And I want to consider with you the 4 F's to start with. And this is attributes related to professional ability, to your professional research capability. And so the first one is focus. Is the research focused, or is it diffuse? Now, it must be realistic. It's a balancing act when you put together your plan for your future. It must be big enough to excite the committee, but not so big that it's perceived as you are naive. For example, and I quote, "I plan on curing Alzheimer's disease in the next 5 years." That's naive. I hope you do it, but it's naive. A much better way to say that is, I want to contribute to a cure of Alzheimer's disease in the next 3, 5 years, whatever. Will you focus short term and diversify long term? This actually is a good way to think about it. The focus short term should be doable. Important? Yes, it's important, but it can be accomplished. Because you all know the sayings, publish or perish, get funded or fail. Those are simply the reality of an academic career or a career in industry. And diversify long-term. Now you're getting a little bit more risky. You're trying to excite the committee even more. You have a big idea, something that will in fact move the goalpost. The second F is future. What are your future prospects for success? Need to lay out a plan. It needs to be carefully thought about. It needs to be very clear. What are you going to do in the first 2 to 3 years? What are you going to accomplish? It's important. I need to know that. And then what are you going to do at 4, 5, 6, 7 years, whatever you choose? I usually think 5 years. I'm not interested as a search committee member in a flash in the pan, as they say. I want to see a plan, a carefully put forward plan for your future that has a future. I'm investing in a faculty member for the long term. You always go into these relationships with the expectation that it will be for many years. You're going to cost me, you're going to cost the Gladstone, you're going to cost the university a lot of money to get you set up to be successful. And I'm going to ask, every search committee member ask in the back of their mind or in the front, is this a good investment. Are you the right person? The future is important. The third professional characteristic that I'm looking for is your ability to fund your lab, your funding knowledge. Do you have a track record? You may have a K08, you may not have any sort of an independent funding stream, and that's okay. It's not expected that you necessarily have a track record, but you must have knowledge of the process to get funded. You must understand the funding mechanisms that you will rely upon. At the NIH, what institute are you going to apply to? You have to know that. What type of a grant? Is it an R01? Is it an R21? What is it? What are the foundations, the private foundations that have grants? Specifically, they're often disease for focus organization. Because I may ask you during your presentation, when are you going to apply for your first R01? So you have to know about R01s. You have to know what is realistic. You can't say, well, I'm writing one right now, because unlikely you don't have enough preliminary data. You need to take advantage of your PI or others in your training program to develop writing skills. Maybe they will let you participate with them. Take advantage of this. We'll talk more about funding and mechanisms later. And the fifth S is fun. Are you someone with whom I would like to interact? I'm not talking about jokes and that sort of thing. I'm talking about being pleasant, being personal, being interested in others. This bridges between professional capability and the personal characteristics. It reflects on how you answer questions. What are your facial expressions, your smiles, your ability to engage those 6 or 8 or 10 people that you're standing in front of. So now let's look at those personal characteristics that a search committee is looking for in a candidate. And I'm going to call this the 6 Ds. The first one is drive. Do you have the drive to be a PI? Do you have the drive to head up a group in industry? What is your drive? Do you have passion? Do you have enthusiasm? Are you really committed? When things don't work so well, are you going to throw in the towel? No, you can't. Enthusiasm I'm looking for. This is a tough business that we're in. The profession of being a first-rate scientist. Only our enthusiasm over the years will keep us going, our drive, our commitment. Now I'm going to give you one very quick example, and that relates to Dr. Shinya Yamanaka. Of course, Shinya, who's on the faculty here at Gladstone, is the 2012 Nobel Prize winner for developing the iPSC technology. And he's often asked, how did you undertake such a difficult project? What was your drive? And his answer is VW. Well, what is VW? It doesn't have anything to do with the Volkswagen car. It happens to be a retreat talk that I gave many years ago when Shinya was a postdoc at the Gladstone. And VW is, in my opinion, the secret for scientific success. You must have V, that stands for vision. Where are you going? What are you going to do? What are your plans for the future? What is your passion? What is your enthusiasm? It is anticipating what might be if you stretch. There's an element of risk in vision, in drive. It's a dream. It's bold. It contributes to society. V, vision. W stands for work, actually hard work, to achieve a vision. Do you have the drive, the passion, the enthusiasm? This is a key question. I want this to be clear to me if I'm going to vote to hire a particular person. Now, some of us are more introverted, and we have to turn up our enthusiasm. But you do that by planning and practicing. Others are more extrovert, and extroverts need to tone down a little bit, listen more, speak less. So you need to think about these characteristics. The second characteristic, personal characteristic, is determination. Can you stick up for yourself? As I've already said, some committee members may want to challenge you to see how you defend yourself. For example, a committee member in a recent search said, "I'm not so sure that this is the best approach." Well, how are you going to respond to that? I appreciate the question, I appreciate the comment, but James et al. In 2016 demonstrated X, Y, and Z, and my preliminary data is in line with that approach. But I would really be pleased to get to hear more of your thoughts, and I hope when we have our private meeting, we can really talk about this. So there are ways to handle your responses. The third personal characteristic that I'm looking for is your demeanor. Are you a colleague to be proud of? Do you act like a professional? I'm interested in being associated with professionals at all levels. Fourth is dialogue. Are you able to communicate your science, your goals, your aspirations? How well have you developed your ability to communicate? You're standing now in front of the search committee. How well can you share your goals, your aspirations? Do you have an elevator speech, a 1 minute, a 2 minute, a 3 minute? Have you developed good oral presentation skills? Now, I often tell young scientists that 50% of your success will be determined by the excellence of your science. No question about it, the excellence of your data, but the other 50% is determined by your ability to present your science. Here we are talking about a dialogue. Next, as a search committee member, I want to be, I want to be proud of you. So how are you dressed? Do you look like a professional? Now you may guess that I'm rather conservative, and I expect candidates to be appropriately attired. I'm not so good at explaining and describing women's attire, but you'll get the idea when I tell you what my expectation would be for the dress of men seeking a job at the Gladstone Institute. Or California and the West Coast is different than the rest of the world, but if you go east of the Rockies, Hopkins, Yale, Princeton, in that area, I think men should definitely wear a sport coat with a collared shirt, but I also think they should wear a tie. You're not going to offend anyone, and you can always take it off, but dress is important. I want you to look like a professional. We once had a candidate that showed up. This was a few years ago now, so no one will remember this candidate. He wore a t-shirt with the tail hanging out of his pants. That equaled no job right off the bat. As I said, I'm interested in being surrounded by professionals. And then the sixth D has to do with dinner. Usually there's a dinner associated with the recruitment, and this is not a time to relax. This is not a social event. This is part of the interview process. In fact, it's one of the important parts, because you really, the person lets down a little bit of their guard and you really begin to know them. Be sure that you know who is going to be attending the dinner so that you can look them up. Maybe it's search committee members, or maybe it's a couple of new people that the committee is seeking advice from. So you need to show interest in them and what they're doing. It's a good time to have more of a group-like discussion, and there's nothing wrong with you orchestrating some of that discussion. Don't talk too much. I've already said that. Listen for clues, but you can always ask really interesting questions that show an interest in the people that are at the dinner. So what is your advice for a young scientist in choosing their first lab or setting up their first lab? How did you decide to come to UCSF? In your career, was there a mistake that you actually made? So you can show interest, seek advice, and this is a good way to interact. But as it says here, maybe this is a little too strong, don't drink, but be careful. No double martinis for most of us, I would suggest. So there you are, the 4 F's. Focus your research, needs to have a future. And of course, ultimately, you're going to have to fund it. But I'm interested in you as a person. Are you fun to interact with? I want to know that you have drive, that you have a vision, and that you're determined to make a difference, that your demeanor is one of a professional, your dialogue is direct, your dress is appropriate, and you are an interesting dinner guest. Are there any questions at this point? I assume you can unmute yourself and ask. I hope.
Dr. Mahley.
Yes. Hi. How you doing?
Yeah, I'm good. Thank you. How are you?
You took the course a few years ago.
Yep. So is dinner it's a mandatory nowadays. Mostly it's in over Zoom. So.
Oh yeah, we're talking about the future. Which I hope the future is very soon. But of course, right now, and for probably the next few months, we're in a Zoom world, and that's a different beast. I hope, but Zoom has many capabilities. I'm not going to talk about them, but I've seen some absolutely beautiful Zoom chalk talks by candidates that just recently. And the same principles hold because you're in front of a camera and there is a board behind you, and you have to learn how to use that board. And it's a challenge for many people. It has to be centered just right.
Yeah.
So that both edges are on. We've seen chalk talks where we couldn't see, the first words on the entire right side of the board. So it takes some effort. But and dinner, of course, right now, and of course in just the last few days, we're back to masking and attending restaurants. But now I'm talking about the future I hope the near future. So anything else about the dinner or anything that?
So the other question I have is that now, how often people use a board, physical board, to give a chalk talk versus on an iPad? Because some people also used to give in an iPad and then they put that and connect that to your Zoom meeting to give a chalk talk.
Yes.
And do you have any bias? I mean, do you have any preferences? What works out better, a physical board on your back or a
No,
iPad connected?
You can use the iPad, which can work very effectively. It's really the same principles that we're talking about. It's just a different technology. But soon, we're all, when we give chalk talks, we're all going to be standing in front of a whiteboard. So actually, it's much better. Because you can interact better with the search committee members, because you're one thing, you're in close proximity and you're looking at them. And that's very important. We'll talk more about that.
Dr. Mahley, we have a question. Have Zoom candidates used the Zoom whiteboard feature, and was it a useful alternative?
Yeah, it's a very useful alternative. And within the last 3 or 4 months, I saw an absolutely outstanding chalk talk using that modality. It works very well as long as you are capable, as long as you can manage the technology efficiently. Because another person tried that again within the last few months, and it didn't work so well. But it was simply that she had not practiced. She would have done fine otherwise. Okay, let's continue, and let's talk about the do's and the don'ts in chalk talks. So let me talk about don't things that you don't do. Don't repeat your seminar. You give enough background so that anyone can understand what your aims are, but don't repeat your seminar. There's an expectation that search committee members had attended your seminar. Now, it may have been a month ago, and I may not remember some of the details. So you just give me enough to jog my memory, but you can't do the whole seminar over again. That's the wrong approach. Don't use slides. Once, 2 or 3 years ago, a candidate showed up to do what was called a chalk talk. And he had been told that we don't use slides, but he brought his slides. Well, the room wasn't even set up to show slides, and he then was flustered. There are no slides in most cases. More recently, a candidate showed up and said, I have a few background slides just to set the stage. And the chair of the committee said, oh, okay, but let's get to the dialogue and the whiteboard as soon as possible. Well, he drug it on and on with his slides, and pretty soon she said, no, we'd really appreciate it if we could just have a discussion. And that didn't work so well for him. Don't turn your back on the audience excessively when you're writing on the board. It takes some planning as to how you're going to do that. And don't get flustered by being interrupted. This is not your agenda. The committee has their agenda. They've heard your seminar and they have questions, and they want to know you better. So you have to go with the flow. You're going to be interrupted, but don't let that fluster you. Now, do build on the seminar by talking more about where your science is going. Expand your specific aims. You probably had a future aims in your slide presentation, but now's the time to flesh out those aims to discuss the future. Keep your presentation simple and clear. Do remember the KISS principle. Keep it simple. You're going to list aims in your presentation. Typically 2 or 3 aims and a 2 and a 5-year plan. Demonstrate knowledge of search committee members' expertise and refer to them if possible and natural. Don't make it unnatural. Make it natural, referring to a recent publication of a search committee member. It sometimes is appropriate. Even a comment like, of course, Dr. Jones is an expert in this area, but let me tell you what I'm trying to do on this particular topic, something like that. Try to lead the discussion because you want to get through all of your aims at least. You want to do that. But so try not to get hung up too early in your presentation. And if it's true and correct, you can short circuit a question that could derail where you want to go by saying something like to the search committee member, I believe it will become clear as I present aim number 3 or whatever it might be. You have to answer the question if they press you, but you do want to manage the discussion. Such a thing as that's a valid point, but may I suggest thus and so as I will elaborate on something along those lines. Indicate the agreement with your PI, the person that you're working with right now, about the future. Often your PI has a big lab. Some of the projects that you know about and you were involved in are ongoing. But you know, it's if you're an assistant professor starting out, it's difficult to compete with an established big lab. So work it out with your PI about what you're going to do and the links you'll continue to maintain, but you're not going to compete with him or her. And demonstrate during your presentation enthusiasm for being considered by the institution. I'm really pleased to be considered for this position by the Gladstone Institute. A simple statement like that suffices. So let's talk about tips for success. The most important thing that I can say to you, if you remember nothing else, remember that you need to practice, you need to practice, and you need to practice again. Giving a chalk talk, in my opinion, is much more difficult than a slide presentation. So you must prepare. This is not an informal chat. This is a formal presentation without slides. Some technical issues to consider. Always bring your own pins. You can't rely upon those that are sitting on attached to the board. Plan out the use of the board. Now, you may not know exactly the size of the board until you get into the room, but you need to draw out on paper how you would like to lay out the board. For example, in the demonstration chalk talk that I'm going to give to you in a few minutes, this is my outline. What I'm going to put on the board, what I want to say extends here to another page. Now, I'm going to keep this with me during the presentation, so I don't get lost. I'm not going to read it or anything, but I may have it on the table so I can glance at if I need some pointers as to where I should be going. Try to arrange 2 to 5 minutes to put something on the board as the committee is assembling. This is always allowed. I've never heard a chairperson object to taking 2 or 3 minutes. The search committee assembles slowly. They may actually be eating their lunch, so forth. So it's usually totally acceptable to have 2, 3, 4, 5 minutes to put something on the board, to put your aims, to draw a model or a diagram. I saw a beautiful presentation a few years ago. It was about congenital heart disease. The person drew a beautiful heart, a mature heart, and then different stages, one on each side of the heart. And as she gave the talk, she wrote first heart field, second heart field, and so forth. It worked. It was a beautiful chalk talk. If you can do that sort of thing, I'm no artist. I can't do it. She was. I've also seen people prepare a table. Maybe aims down one side and across the top, different categories. And as he went through, he put a check here. He put a question mark in this other box. He put a minus here, so it worked nicely. You can think about different ways to do it and use the board left to right, top to bottom. And importantly, write large. Now we're talking about being in a conference room. Zoom is a different beast, but hopefully this Zoom for Chalk Talks will go away, as I've already said. So you need to learn to write large. You have to assess how big the conference room is, how many people are going to be attending. So now let's get more specific and talk about the structure of a chalk talk. There are a number of ways to do it. I'm going to suggest that there are 3 components for you to structure your talk around. The first is the background, and then we'll talk about aims, and then we'll talk about funding. But let's start with the background that you need to provide to the search committee. The background is to remind the search committee of the key points in your seminar. You simply make them. You don't try to prove them. That's what you did in your slide presentation. Enough so that they can understand your specific aims, and enough to excite the committee. Now remember, some may not have attended the seminar. If you've got a group of 10 or so search committee members, sometimes a lecture gets scheduled when one member can't attend. Or it may have been a month ago and they just don't remember the specific facts. This is not uncommon. Remember, they're busy people, and you need to provide just enough. And I'll give you an example of that in a minute. The second part of the chalk talk that should go on the board in some form we'll talk about are the specific aims. Now, usually there are 3 aims. That's how we envision a R01 grant. This works nicely. It shows that you're actually thinking about funding already, and you have aims. Consider the scope of the aims. As I've already said, the scope should be 2 to 3 years, and that needs to be doable. In fact, you've already got some preliminary data from your postdoc year that suggests that one of your aims is going to be doable, and then your 5-year plan is more risky. It can't all be risky because, as I've already said, you'll be considered naive and you won't get funded. However, a successful candidate undertakes exciting projects long-term that are in fact somewhat risky. The third component is funding. Like it or not, if you're seeking an academic appointment, you're ultimately going to have to fund your lab. You need to have a timetable for funding. I suggest something like 5 years. The timing of the undertaking of the aims needs to be clearly stated. Usually, when you're starting a lab, you can't do all 3 aims at the same time. It's not always true, but usually you have to do it in some sort of an order, and you need to let the search committee know what the timing is for the aims that you're undertaking. And then you need to tell the search committee about the timing for funding and the type of funding you're looking for. The NIH, foundations, named awards are all possibilities. But you need, as I've already said, you don't have to be funded, but you have to have the knowledge of being funded. So, background, enough to understand, specific aims, short-term, long-term, funding, how you're going to go about it. These are the 3 components. And then also remember job considerations from your perspective. Not only are they interviewing you, but you're interviewing them. Are they good colleagues with whom you want to work and which you can be successful? And you look for red flags. Is there an individual at this university, this institute, this organization that would see you as competition? That's my turf. You really shouldn't work on that. So that's a red flag. Be sure you want to work with these people, because this is a place that you're going to have to be happy to live and work for 5 to 10 years. You know, that's a typical tenure for the first stop is 10 years. It can be longer, but it's got to be a place where you want to live. You're not just going to be in the lab, you're going to have a life as well. Are they providing you with what is needed for you to be successful? What about the financial resources? What's your startup package? Is it enough to really launch you for the first 2 or 3 years until you get enough preliminary data for a substantial grant? What core facilities are available? You know, you need a mass spec. Well, it's unlikely, you know, they're going to buy a mass spec, but is there a core facility that you can interact with? And are these cores open to other faculty members? What about mentoring? Does this look like an organization that will mentor, that will boost you, that will promote you? And it's an intellectual environment that's exciting. Will you have room to grow in this organization? Grow in space, yes, but grow in excellence, in expectations for future success. Now, a postdoc at the Gladstone has now a wonderful position as an assistant professor. But one of the messages that he came back and told us all after he had completed his search and made a decision. And the statement reads as shown on the bottom here: collegiality, he said, trumps prestige of the organization, and it trumps finances. Collegiality. Is it a place with good colleagues with whom you want to work? I'll stop there and ask for questions before I give you a demonstration chalk talk. Are there questions? Please feel free to unmute and ask them.
Hi, Dr. Mahley.
Hello.
Good to see you. Thanks so much.
Wow,
Good to
you're
see
welcome.
you. I had a question about, so your last point about, you're also trying to assess whether they'll be able to provide the resources that you need, whether it's equipment or financially. How much of that should influence what you talk about in your chalk talk? So for example, if you're talking about certain experiments that you want to do, but you're either not sure if you will have access to those kinds of facilities or resources, should you
Well,
try to adapt your aims in chalk talk to that, but you don't want to come off as not being ambitious or
right.
bringing new exciting techniques. So.
Yeah, a very good point, and an important point, and I'll try to illustrate that when I give this makeup chalk talk. Um, uh, but yes, you should acknowledge that a certain core exists, and it's nothing wrong with mentioning that. I'm going to contact Dr. Smith, who runs that core, to see if he or she will help me to accomplish aim number 2, or something like that. No, there's no reason. In fact, that shows knowledge of the organization, and that you're serious, that you're a serious candidate, that you want to be considered for this job. So yes, you can insert such things. Some of the details about availability, how much do they charge for a particular assay, that's done one-on-one at a later stage. Right now you want to get the job offer, and then you can dig deep and find out if this is a good match for you. Collegiality trumps prestige. Harvard, Yale, Princeton, whatever. Collegiality at the University of Alabama is more important to you than the name Hopkins. So do consider that, yes.
Dr. Mahley, we have a couple of questions in the chat. The first question is, how many candidates are typically invited for Chalk Talks?
Yeah, how many candidates are typically invited? Well, the last search that was just completed, I think there were at least 6 candidates that were invited. It was casting a very broad net, and so there were different areas of expertise. It was more of a generalist position, and so there were a number of candidates. Now I've seen other searches where there are only 2. We're down to the last 2, and now we have to make a decision. And the Chalk Talk will be the determiner of who gets the offer. So it goes all over the place with the number.
And the second question is, for these 2 to 3 aims that you're speaking about, should folks prepare both short-term and long-term scopes for all 3 aims, or keep short-term scopes for the first aim and long-term for the other 2 aims? Can you elaborate a little bit on that?
Yeah, I think the way the question was stated, I agree with. The first aim usually is something that can be accomplished in 2 or 3 years, because that in part's going to be the basis for your funding, the preliminary data that you generate. And then as you get deeper into the aims and expand the scope of the project, it goes out for a longer period of time. So in general, I agree with your comment.
Hi, Dr. Mahley. I was just wondering if you had any specific advice for computational scientists giving a Chalk Talk?
Yes, it's the same as we're talking about. In fact, the search that I was referring to, which you may or may not know about at Gladstone, was one that had a computational element to it. And it was exactly the same. Maybe I don't understand the intent of your question.
I guess my feeling is that often computational scientists will come with a much broader and less hypothesis-driven approach, and I was wondering if that you sometimes that's like not uncomfortable, like problematic for the Chalk Talk, maybe.
Yeah. No, I think the general principles apply for hypothesis generated or not. We just went through a series. I just didn't see a problem, at least as expressed by these candidates.
Cool, thank you.
Then let's continue, and I'll try to illustrate some elements of a Chalk Talk by giving a makeup demonstration Chalk Talk. Of course, in the actual Chalk Talk, you're going to be using a whiteboard, and I'm going to be using slides because to try to illustrate what I would be writing on the board and what would be on the board. It's not as good as seeing me standing in front of a whiteboard, but I hope you get the idea of how to put together a Chalk Talk. So this is what I'm going to put on the board. I've asked the chairman for 3 minutes. I can do this in 3 minutes. I can write the title, and I can put in the first block is background. The second block are the specific aims, the research I want to conduct. And then there is a vague line here, which is my funding. Now, I may never get through all of this because they may get hung up on my work on a protease, and there just may be umpteen questions, and I never get to the funding part. That's not unusual, and actually that's a very good interaction with a search committee. But they know that I have a plan, and if I have 30 seconds left, I can refer to this, my plan for an R01, a foundation grant, and then the Department of Defense. I can do that in 30 seconds. I'm not giving you any detail because I didn't have any time to do that. The chair told me you have 2 minutes, 5 minutes, whatever it is to finish. So this is really an outline of what I want the committee to understand. Now, I keep it as simple as I can. I use 2 colors. I don't try to juggle 3 or 4 markers. I use 2, black and red is what I will use. So in black, this is what I put on the board, as you see right here. And then in red, I add sequentially to this outline. It helps me to remember where I'm going, but it helps me to show the search committee that I have a plan. It's carefully worked out, at least I hope it is, so the committee can get to know what I really want to do. So let's go with this made up Chalk Talk. Well, thank you for inviting me back to the Gladstone. I'm really very pleased to have this opportunity to share with you what I hope to accomplish in the next 3 to 5 years as I establish my laboratory here at the Gladstone Institutes, if I'm given that opportunity. As you may recall from my seminar, my postdoctoral training focused and I'm pointing to this, the role of ApoE4 in neuropathology. Now, our first clue as how ApoE was involved in neurodegenerative disorders came from understanding the structural differences that distinguish ApoE3 and ApoE4. Let me remind you, I underline this just to call attention. Let me remind you that there are two major forms of ApoE, ApoE3 and ApoE4. ApoE3, I'm writing this now, is the most common form. However, However, ApoE4 is not rare. It occurs in 20 to 25% of people worldwide. ApoE4 is important in the pathogenesis of Alzheimer's disease and in traumatic brain injury. And I shared with you some of this in my slide presentation. For example, in Alzheimer's disease, ApoE4 is the major genetic risk factor. Something like 60 to 80% of all patients with Alzheimer's disease have at least one copy of ApoE4. ApoE4 differs from ApoE3 by a single amino acid interchange. In ApoE3, and I'm writing cysteine 112, whereas ApoE4 has arginine at this site. This interchange has a profound effect on both the structure and the function of ApoE4. ApoE4 has a unique structure. It's called domain interaction that I did say more about in the slide presentation, in which arginine 61 interacts through an ionic interaction with glutamic acid 255. And because of this arginine at residue 112, the side chain of arginine 61 extends away from this amino terminal domain and is available to interact with glutamic acid 255 in the carboxy terminal domain. In ApoE3 with cysteine at residue 112, the side chain of arginine 61 is tucked more into the amino terminal domain, and it's unavailable to interact with the carboxy terminal domain. And so it is this abnormal structure of ApoE4 that's associated with neuropathology. Now, when ApoE4 is synthesized by neurons, it undergoes proteolysis, generating a series, I draw an arrow, to neurotoxic fragments. The fragments enter the cytosol and they interact with a number of organelles, but I'm talking about the fragments interacting with mitochondria, causing mitochondrial dysfunction. You may recall from the preliminary data demonstrating that if we block this domain interaction, this interaction between arginine 61 and glutamic acid 255, we correct the abnormality of ApoE4, and the block can occur by the use of small molecules called structure correctors. And these structure correctors prevent the ApoE4 associated neuropathology. These ApoE4 structure correctors convert the E4 to an E3-like molecule without this domain interaction. And we've identified a series of structure corrector molecules, and I'll say more about that in my new work in just a minute. So this is what I consider the necessary background. Those of you that were at the Art of Lecturing last Monday will know that I presented some of this in the demonstration portions of a demonstration slide presentation. So I've simply tried to remind the search committee in probably 5 minutes some of the details that I showed in the slide presentation. Only the details that they need to know, not the details of how this interaction occurs, or I'm not at this point even going to describe the fragments except to say they exist. So does that, I hope, make sense to you as background? And it's simple. I didn't have to do a lot of writing. I was set up with what I had put on the board so that I could do very little writing, but make a story out of what I had here under the background. So now let's consider the aims of the research that I will conduct. And there are several steps in this pathway that need, I'm now speaking to the search committee, there are several steps in this pathway that need to be fully elucidated if we're going to understand the role of ApoE4 in neuropathology, and that is the major goal of my laboratory. The first step relates to the abnormal structure of ApoE4, and the question is, can we correct the abnormal structure of ApoE4, and so doing prevent some of the characteristics of the neuropathology using the small molecule structure correctors? The data that I presented in my seminar used a small molecule that was called PY101, and most of the data that I presented in the seminar was in vitro studies. But now, as I establish my lab, I want to focus my attention on in vivo studies, and I will be using the ApoE3 and ApoE4 mice. Now, I'm very fortunate that my mentor, Dr. Yadong Huang, has agreed to provide me with 2 breeding pairs of the E3 and the E4 mice, and this is going to allow me to quickly get started on my research. I've identified now in my chemical structure work 3 distinct series of small molecules structure correctors, and they are pyrazolines, pyrazoles, and sulfonamides. And these new compounds have several advantages over the compound that I talked about in my talk, because these new compounds are more potent, they're nanomolar compounds, and they penetrate the blood-brain barrier. My pilot studies have been conducted using intraperitoneal injections. However, to advance these studies, I must develop an oral formulation for the administration of the small molecules. And the compounds that I have identified as structure correctors are rather lipophilic. And so I'm going to need to solubilize them, and I have been using oleic acid with some success. I can go into much more detail about the formulation that I'm trying if you would like, but hopefully some here on the committee will be able to provide me some advice. And in fact, I know that Dr. Ding, who's seated here in the front row, that his lab has a lot of experience working with small molecules and in vivo administration and formulation. And so I will be asking him to help me to finalize the formulation. Now, the readouts that I will use to characterize the effects of these structure correctors include histochemistry and behavioral biology. I'll use synaptophysin and MAP2 for the immunochemistry to determine the protective effects of the small molecules. And recall that I've demonstrated that ApoE4 expression causes neurodegeneration in the hippocampus. Now I'm going to use, for the behavioral studies, I'm going to use the Morris water maze to analyze learning and memory. And the E4 mice, as I showed you in the talk, are defective in these parameters. And the question will be, can the structure correctors administered to the mice prevent the cognitive abnormalities? Now, I'm aware that Dr. Zhu here at the university is an expert in behavioral biology. And in fact, I've already spoken to her, and this will be a big help as I set up my behavioral biology measurements. The second step in this pathway involves understanding the protease that generates these neurotoxic fragments. And in my postdoc, I was involved in helping to identify this protease. The work's not entirely completed, and it's ongoing in my mentor's lab. Now, I'm aware that identifying this protease is a major interest of his, and I will profit from staying in touch with him as he identifies the protease, but I'm not going to work on the identification of the protease. However, I will focus on the identification and the characterization of the fragments that are generated and to determine where the cleavages in the ApoE4 actually occurs. As I showed you, there are 6 or 7 different fragments that are generated in the ApoE4 conditions. They range from 12 to 29 kDa, and we know that the fragments are associated with neurotoxicity, including being able to, some of them at least, interact with mitochondria. But truly, we don't know if all of the fragments are toxic, and we don't know that all of them interact with mitochondria. So this is a major question that I'll undertake. And I'll isolate the fragments generated by the ApoE4 expressing mouse, looking at the brain, characterize them by mass spec. And I spent the last 6 months interacting with Dr. Krogan at the Gladstone to learn the techniques of isolation and purification. And I'm sure he'll be available to help me as I continue to undertake this characterization of the fragments. Now, as an aside, I can go much further. I can talk about the approach and so forth, but this is just an example. So the third step, now I'm back to the talk, in the pathway involves understanding how ApoE4 and its fragments alter mitochondrial metabolism. Now, I'm very excited about this aim because it's becoming more readily recognized that Alzheimer's disease involves mitochondrial dysfunction, and this is especially true in ApoE4 associated Alzheimer's patients. I've shown that the fragments, or at least one of the fragments, the large fragment, interacts specifically with mitochondria. But now I want to extend this work to determine how the fragments alter mitochondrial activity. I'm going to expand the data related to mitochondrial respiration using the seahorse and measuring ATP production. Major goal of this work, however, will be to excuse me, to determine which fragments interact with mitochondria and to what do these fragments interact with on the mitochondria. It appears that the fragments do not enter the mitochondria, but interact with something on the surface. And I've shown that the large fragment does interact with mitochondria, and we'll go on to look at the other fragments. Now, the preliminary studies demonstrate that the fragments interact with VDAC1, the voltage-dependent ion channel on the surface of mitochondria. This is a major protein playing a major role and so forth. I can go on and talk about VDAC. I've developed the proximity ligation assay to localize the interaction of fragments with VDAC1 and I can describe that approach if interested. And finally, I will use the most potent of the structure correctors that I've been studying to determine if they rescue the effects, prevent the fragments from interacting with the mitochondria by maybe modifying the protease or in some way interacting with the mitochondria. So that's the aims part of the demonstration. It can be expanded as necessary. If time's running out, I can shorten it. For a 50-minute talk, this part of the talk may be 25 minutes in length, the way I've planned it. But you will have to play that by ear. As I've said, it's not your agenda, it's the search committee's agenda. And then I will end by talking about the timeline. So let me share with you the timeline and the funding that I envision in establishing my lab. Initially, I'm going to focus on aim 1, the effects of the structure correctors and the transgenic mice, because this is the part of the work that is the furthest along. And the startup package that you're providing me will allow me to hire a research associate and a summer student to help with this characterization work in the mice. But I will also, as soon as possible, continue my work on mitochondrial metabolism. As soon as I have enough preliminary information about the data in the mice, I will submit a proposal to the Alzheimer's Drug Discovery Foundation. And then this is a $125,000 grant over a period of 2 years, and this will allow me to recruit a postdoc to advance the studies. And although I will focus on the structure corrector work, I'm also going to be involved in characterizing the fragments and preparing for the mitochondrial studies. Now, by the beginning of my second year, or maybe a little later, it depends on how the data comes, I'm going to start writing an R01 grant that will be submitted to NIA, and this will likely focus on the structure corrector and the fragment characterization. My long-term goal, however, is to extend my studies looking at the role of ApoE4 in traumatic brain injury. This is a huge problem affecting millions of people around the world who have had trauma and develop the syndrome that disrupts memory, cognition, and function of various aspects of life. There's a poor clinical outcome when you have ApoE4, and I would want to understand this, and I will explore establishing a mouse model, a cortical impact mouse model, to study this in the context of ApoE4. And this data will allow me to apply to the Department of Defense. So that's something like a makeup demonstration talk that I wanted to share with you. The 3 components: background, specific aims, and the timeline for funding and for undertaking the scope of the specific aims. So let me stop there and ask if there are any questions. While you're thinking about your questions, let me add one other thought, and that's a summary, because often you come down to the last minute. You may only be on aim 2, but the chair says, Dr. Mahley, we have only 1 minute left. Would you like to summarize what you hope to accomplish in your new lab? And so you need to have an elevator speech, depending on the time that he or she gave you. And so mine is something like, as I establish my own independent laboratory, I hope to contribute to the understanding the mechanisms whereby ApoE4 causes neuropathology. First, I will explore the use of small molecules, as I have described, in preventing the detrimental effects. Second, I will characterize those fragments. That's critically important if we're really going to understand how the fragments interact and cause pathology. And third, determine exactly where those fragments interact, with what proteins they interact, and then move on to the mechanism whereby this interaction causes mitochondrial dysfunction. And I will apply these observations to both Alzheimer's disease and traumatic brain injury. And thank you very much for allowing me the opportunity to share my thoughts, and I look forward to our further discussions. Thank you. All right, questions?
Hi, yeah, I have a question about how you spoke about AIM-1. It seemed like that as the applicant, you had like the least experience with working with these mice or using mass spec. And, you know, so you said you were excited to work with these other people, but how would you find the balance between saying you're interested in working with other people, but you would still have the, I guess, expertise, or you would still be okay on your own, you know, if they're busy, for example?
Yeah, that's an important question. It's a fine balancing act. You're absolutely right. You don't want to say you know everything, because one thing, you won't be believed. But the other thing, you've got to have enough experience to do something. Actually, I have a lot of experience in studying ApoE3 and ApoE4 transgenic mice. And I've been looking at the small molecule chemistry for the last 5 years. So I didn't portray that description very well. Of course, I made up this whole thing to try to illustrate. But you're right, your point is well taken. Now, I don't have much experience with mass spec, either as a makeup candidate or as a real candidate. And so I need Nevin's help in that regard, and I'm not bashful to indicate that I've started work with him and I need more help. Does that help, Stephanie?
Yeah, it does. Thank you.
Okay. Other questions? All right. I'm sorry.
Sorry about that, Dr. Bailey. We do have one question in the chat. How much does the chalk talk get interrupted by questions? And does it happen that a candidate does not fully finish a prepared chalk talk?
Oh, yes. Yes, you often don't finish a prepared chalk talk. That's why I suggested if you're doing a 50-minute chalk talk, you prepare something like 35, because you're going to be interrupted repeatedly. That's the purpose of the chalk talk for the search committee, is to drill down on how you think and how you react to questions and comments. It truly is a dialogue, and they're trying to learn. They're trying to learn how you operate. And so you will be interrupted. And yes, it's often true that you will not finish your prepared comments. That's why I put all of these things on the board that I consider important. Because if I get hung up on the protease, I want everybody to know that the ultimate goal, and they heard it in my seminar, is to study mitochondrial metabolism. And I'm going to take 30 seconds to explain that. I can't explain it well, but I've only got maybe 30 seconds. And then the other reason I drew this strange line and put 5 years here is simply to indicate to the search committee, I have a plan. I have a plan. I may not have time to present it to you, but I have a plan, and it's a 5-year plan. And they're going to want to know what those little tick marks are. And that will become a point of discussion when I meet with each of them privately.
Dr. Mahley, we have one more question. How much of the extramural funding is expected by the search committee in general?
It all depends upon the complexity of the study. I can't give you a real number if that's the intent of the question, because it depends upon the complexity. It depends upon how much they are going to give you as your startup funding, and that's a negotiated number. And it has to be enough to allow you to hire at least 1 to 1.5 people so that you can generate enough preliminary data to get the bigger awards. There's nothing wrong with this ADDF. 125,000 is going to get you a postdoc in addition to what your startup funds are. We usually don't expect an entry-level assistant professor to bring money. And you must be prepared to make sure they provide you enough for your success.
Dr. Mahley, I think we have time for just one last question. If a discussion on a detail takes a long time, should I wind it down and focus back on the talk, or just continue to discuss the current point until there are no more questions?
No, you answer the question as quickly as you can, and you can always make a statement like, I would like to discuss this in more detail with you after the chalk talk. Would that be all right? Could I do that? So you do it very politely, modestly. But you want to get on with your prepared chalk talk. All right. Well, thank you all very much. It's been a pleasure, and I'll turn it back to Emma.
Thank you so much, Dr. Mahley, for your time and for your dedication. And thank you again to our colleagues from Gladstone Institutes, UCSF, Genentech, Lawrence Berkeley Labs, and UC Berkeley and UC San Diego. And I hope you all have a great rest of your afternoon. Thank you.